Hello there, folks. We're going to build another video this time to talk to our E3 I/O, and I've already got it configured on my network here as an IP address of 192.168.1.21. And so what I've done here is I've got a RedLion Crimson 3.2 database built that's going to simulate a G07 HMI. And in this case, if I go over to communications on the left, I want you to notice that on the protocol 1, that I have chosen the RedLion for the manufacturer, and I'm using the driver specifically written for the E3 I/O, and that's the driver I'm using. Then right below here, normally this will say PLC1. I changed the name to the actual model I'm using, and then you can also hit the pull down here, and that'll make the I/O mapping maps that particular device. I haven't changed anything else other than the IP address here for this particular unit. That's what I'm using here. And then over in data tags, I've got a series of data tags already set up. Let me show you something. On the data tags, you're going to wonder, where's the data mapped to? So if I go look at a data sheet for the E3, actually, I'm going to go to my online access, or, you know what? Hold on here, team. Let me go to Crimson 3.1. If you open up Crimson 3.1 and you do File New and you select the particular product that you're looking for, what E3 module. When you do that, if you click on I/O channels over here and then click here, it'll actually show you the Modbus mapping for that particular unit. So you can see here discrete inputs. These are going to be my DIs right here. If I slide down, here's my discrete outputs, 1 through 8. My analog, these are the 3000 holding registers, or not holding, I'm sorry, 3000 analog input registers. And then down here, the analog outputs, these are going to be my 40,000 holding registers that these map to. So on my database here, if I look here, I've got a bunch of flag tags because digital I/O is going to be a flag. In PLC code, you call those Boolean. Here in RedLion software, we call those flag tags. You can always select those by hitting the pull down here and create a flag tag. That's a Boolean tag here. And you can also tell by the shape. Anything that's a flag here is a Boolean. So if you look here, DI1 I made first, and I went out to here, and I went down and I pulled that device, and then I hit the pick button here, and it's going to bring up a listing of all the stuff that's available. So I'm looking for the discrete inputs. So as I pull down here, you can pick the other stuff, but I'll do DIs here, digital inputs, and then in this case, I'm going to go ahead and select onboard, and I'll do bit number 1, click OK, and that's the first guy, and the next one is number 2, number 3, and so forth. And the beauty to this is when you set up one of them with the DI_1, as you hit the smart duplicate button, it will automatically increment those, which is really nice. So I set up all those there. If I go down here to another folder I call digital outputs, so here the same exact thing. I got a flag tag. Notice it's red because it's going to be read write, whereas if I go up to the previous ones, these are all green because they're inputs, so they're going to map as read only. So anyway, these guys here, same exact setup. I'll go over here, pick the E3 module, and then I'll pick the discrete outputs for my pull down, and I'm going to do onboard outputs here. I'm trying to interact with those. And again, you'll see that's output number 1. And as I do smart duplicate, as you click on these, click the smart duplicate, it'll automatically increment them for you. Same goes for down here for analog inputs. If we go to analog inputs here, whoops, let me go to the data tab. Notice these are all going to be not a flag tag. These will be a numeric tag because they're an analog value. They'll be an integer value in this case. So you get an X here for these. And on this one, when I go down here and pick the unit, hit the pick button here, I'm going to be looking at my analog inputs. So I'll be doing I/O channel analog inputs. I'm going to click here. It sets it up as analog input 1. These are all words. So I'll do OK there. And again, the smart duplicate goes down. That's all I've done here. And then if I collapse that tree and go to my analog outputs, again, same thing here. It's an X because it's a numeric. Map to that thing there, hit the pick button here. I'm going to go down to my analog outputs, and I'm doing my onboard here. And this is output 1. And then again, if you hit the smart duplicate, it'll go down and automatically increment this for you, which is awesome. So, and those are red because those are writable for this case. So that's, and I'm using for all of these the tags that are built in the RedLion driver. I think after I get done with this, I'll show you how to build it with a generic Modbus device. And then over here in display pages, I've got a little app running here that goes through this, and then on the E3 page, I have simply dragged those tags out here for us to interact with it and see it happening. So let me go ahead and download this to my emulator. This little button here turns on the emulator. If you haven't used the emulator, I've got an example video of that. Search for emulator on my channel, you'll find it. But if I go down to the link pull down and click options, the one caveat to this, if you really wanted to talk to RedLion, is click the configure button here, and then you got to tell it what particular adapter. I'm using a USB to RJ45 Ethernet connector, so that's what it's going to use. I'll click the OK button. Let's go ahead and download this to the emulator. Let's see what happens. So here's the emulator. Here's my raw face. It's running right now. If I go to my E3IO page, you can see here. Now I happen to have a thing that's flipping and flopping my inputs here, so you can see that change here. But if I go and turn on one of my outputs here, that's wired to this guy here, and that's basically on this wiring that I've got here, jumping that wiring. That's what's happening right there. And if I go back to here, if I turn on another one, you can see it's wired to this input here. If I turn on number 3, this should turn on this input here. Where did that one go? Hold on here, let me do that again. It's down here. Oh, they must roll over. Okay, yeah, that's a rolling over. Anyway, so those are direct wired in here. And then if I go over to my analog channels, now you can see right now that the analogs are showing some values because they are hardwired. Whoops, that's not the one I want to show you, the wired face. I have these wiring going from my analog inputs here. My outputs are mapped to the first 4. So they're just direct connected, and that is causing just a small signal here. Also, what's kind of cool about that is that on the raw face, you'll actually get LEDs on indicating anything connected, which is pretty nice there on that case. But I do want to show you something. If I go over here and put in an analog value, remember this is 0 to 32,767 for this guy. So if I put in 16,500, we see the corresponding input comes back to that value, which is correct. If I go to another channel, whoops, let me go to the next channel here. This guy right here. And maybe we'll put this one at, I don't know, 2,300, for instance. You can see it reads there. And if I put another one at, I don't know, picking some numbers here. So there's those channels all working on that particular unit. Pretty cool little demo here. I'm using the E3 simulator. I'm using a G07 simulator to talk to a real E3 IO. And on the unit, I actually created LEDs here. So these are actually the true LEDs that are showing up on the face of that unit, which is pretty darn cool. I wanted to take this one step further. Let me go back to RedLion here. And the driver I'm using right now is the E3. Let's go ahead and pick real quick here, protocol 2. Let's say I want to just use Modbus. I'm using some other Modbus device rather than RedLion, so I don't have a driver written for it. So I'll go to Modbus here. I'm going to choose TCP/IP master. I'll click OK, and I get that PLC1 under here. Let me change the name of this guy to E3, E3 underscore Modbus, for instance. And I'm going to do underscore 21 at the end because the IP address of this unit is number 21. So just to double check, if I click on this guy, you can see here's the IP address of the unit. If I go here, I got the same. Okay, so that should work. Let me go over here to data tags, and I'm going to go ahead and create a new folder. Let's call this E3 underscore Modbus, for instance. All right, and then I'm going to create another folder here for my digital inputs. All right, and then I want to do some flag tags. So I'm going to hit the pull down here. I'm going to create a flag tag because that's a digital signal. I'm going to call this one DI underscore 1, just like I did for the other ones. It's blue because it's not mapped to anything. So if I hit the pull down here, and I'm going to go down to this E3 Modbus right here, I'm going to pick. Now, this is the part that's a little tricky. You might wonder, what do you pick here? Well, hold on here. Let me go back to the other, the Crimson 3.1. Crimson 3.1, if I slide all the way up, digital inputs are in the digital input section right here. These are the digital inputs on this guy. So in Crimson, well, actually any other Modbus application, you're going to map these to what they call the 1000 series. These are the 1000 IOs right here. I'm going to click OK here on this guy. That maps the first one. And let me change this from read and write to read only because it's an input. That should map to the first one. So let's try my little trick here. If I click on it over here, highlight it, click the smart duplicate button, let's see what happens. Oh, this is awesome. Look, it goes DI2, and more importantly, it auto increments. So let's go ahead and put on here, I think there's 8 on this one. I'll just put 8 for now. I'll go down to DI8. All right, so that covers that guy. Looks pretty good. Let me go ahead and collapse that tree. Let me go ahead and create another folder here. Let's call this one Digital Outputs. All right, and on Digital Outputs here, I'm going to go ahead and create a flag tag right there. And I'm going to call this one DO. Now, here's a little to-do thing. You can't really call it DO because for some reason our code thinks that's a function. So I'm going to call it D0_1. That's a little tidbit to bite you later in life. Going, why won't it take a DO? It's because it's kind of a function. Anyway, so I got D0_1 to look like digital output 1. Notice it's blue because it's not mapped to anything. Let me go over here. I'm going to go down to the E3 ModbusTCP. You might ask, well, where is that mapped to? Well, here it says digital coils. Again, let me go back to Crimson 3.1. Digital outputs are down here, or I think they should call these coils, but they don't. But those should be mapped here. So let me go back to Crimson here. We're going to do digital coils. These are the 0,000 registers. I don't know why they call that, but anyway, I'll click there. I'm going to leave it as red because I want to write to it. And I'm going to go ahead and use my smart duplicate here again. And what I'm looking for is this number automatically increments with this. So let me go ahead and just put 8 on here for this one. Now you can't see that down here, but you can also pay attention to right here, the name changes. So there's my digital outputs. Let's go ahead and create another folder here for my analog inputs. I'm going to rename it analog inputs here. All right, now an analog signal is going to be an X or a numeric value, not a Boolean or a flag. So I'm going to hit the pull down here, and I'm going to choose a numeric tag, and I'm going to call this one AI_1 for channel 1. Again, notice it's blue because it's not mapped to anything. So if I hit the source pull down here, I'll go down to my E3, and I'm going to, once again, I'm going to go back to my Crimson 3.1. These analog inputs are mapped to the 3000 series. It doesn't show you that, but that's what they're talking about here. So in Crimson 3.2 here, I'm going to go down to my analog inputs. 3001, word is 1, looks good. I'll click OK. Now the software doesn't know whether this is read and write, but it's going to be read only because these are analog inputs. So let me go ahead and create here a number of these. I think this guy has 8 analog inputs. Notice again, the number changes automatically. So that's number 1, 2, 3, 7, and I'll do one more here. All right, there's my analog inputs, hopefully. And let me create another folder here. And I'll call this one my analog outputs. All right, and let's create a new numeric tag. And we're going to call this one AO_channel 1. All right. And these are mapped to the holding register. Again, back at Crimson 3.1, these here are the holding registers because they're got to be writable. These are readable, so these are the 3000 series. These here are the holding registers. So back here at Crimson 3.2, I'm going to hit the pull down, go down to my E3 here. I'm going to go to my holding registers, 40,001, word is 1, click OK. I'm going to leave this one as read and write because I have to write to it. So that's perfect. Let me go ahead and create. There's my 4 tags for that. Looks good. All right. Let me save it. Now let's go over here to display pages. And this is the E3. Let me go ahead and create a new page here real quick here, team. Let me click here. Let's call this one E3 Modbus, E3_Modbus. I'll do 21. That follows the same suit. Let me change the background color here to white on this page. Okay, over on the right, I'll go to data tags. Let me collapse the stuff we have here. So we were just building this E3. So let me grab all of these digital inputs here. Put these guys on the page like so. Let's grab our digital outputs. We'll drag them out here. Oops. I'm going to try to make them a little wider here. And since these are outputs, team, I'm going to make them data entry. So if you remember this trick from any of my classes, if you click anywhere else, I call that losing focus. And then if I click one time, this little button here quickly turns on the data entry field. Notice how the colors get inverted? That turns on the data entry. I want to do that to all the rest of these, so watch this. I'm going to lasso all these other ones, all 7 of these. You can see down here, Crimson will show you 7 items selected. I will right-click over any of these, and I'll say copy from, and I'll just pick all formatting. Notice the X, it's asking me who do you want to copy this from? I'll click on this guy here. Boom, that became data entry. Perfect. Let me go grab our analog inputs, drag them out here. These are going to be a 5-digit number, so I'm going to make these a little bigger. And then I'll grab my analog outputs like so. Let's go ahead and stretch these guys out also. And I want to make these data entry too. So I'm going to click here, boom, go there, and I'll just do that shortcut one at a time here. All right, that looks good. So I need to do one more thing here, and that is I need to add a button to my menu page to be able to get to this page. So if I go to menu, I'm going to just quickly smart duplicate one of these buttons here, and I'll call this one, right-click, E3, we'll call it Modbus 21. Hopefully it fits. It doesn't fit. Let's get rid of the 21. All right. And then if I go to the Action tab, instead of it going to the E3, I want it to go to that page we just created. So I hit the pull down here, and I'll pick E3 Modbus, click OK. And then the last thing we need is that all these other pages, I have a yellow menu button that gets me back to the menu. So I'm going to right-click, copy that button, and I'll go to my new page as put on here. There it is. And you know what else, team? Give me a second. Now let's right-click and copy this label. Let's put this up here. And let's change the wording of this to say E3 IO Modbus 21. That way we know it's different than the other one. Okay, let's try it out. I haven't tested this before I made the video, so I might crash and burn, but let's try it. All right, so I downloaded my simulator, and now if I go to E3 Modbus, look at this. I'm actually reading the same registers that the E3 page. This is using the driver that RedLion has. This page here is using just standard Modbus registers, whether they're digital, discrete I/O, the coils, inputs, the analog 3000 series, or the holding registers. So here, if I change this guy, right there, you can see that number changes there correctly because I got them hardwired to each other. And if I turn on one of these, how about if I turn this guy off or turn this guy off? You can see the channels here change correspondingly. So that's pretty cool. I'm either using the RedLion E3 driver if you're using a RedLion device, or if you're using somebody else's Modbus master, you're simply just going to go set up the tags and look at the Modbus registers. Again, the inputs will map to the 1000 series, the digital inputs. The digital outputs will map to the coil registers, which they call the 0,000 registers. Here's the 0 for that guy. All of the analog inputs will map to the 3000 series analog input registers, and the analog outputs will map to the 40,000 holding registers because they got to be read and mostly writable cables. So pretty cool little concept, and I'm using the emulator to test all this. So that's pretty neat. And also what I think is cool is that the E3 module I'm talking to right now actually has 2 connections happening to it simultaneously. It has this one that's polling it at port 502, and this one is also polling it at port 502. So that's pretty darn cool. Anyway, I just thought I'd make a quick video of that. Another video I'm going to make on this product is I'm going to show you how to build a simulator to simulate E3IO. That's coming up shortly. Anyway, thanks a lot, team. Have a great day. See you later.